Hey guys, today we're going to look at matrices. I'm going to give you a little introduction and then we're going to look at some operations with matrices. So take out your notes and follow along with me on these guided notes. What do you think a matrix is? Take a second to think about that. It is a rectangular arrangement of numbers, and those numbers are sometimes called an array. They are arranged in rows and columns. Remember, rows go left to right, columns are up, or I should say top to bottom. So if we look at the first example we have over here, I have matrix A. We describe matrix A by referring to the dimensions, the number of rows and the number of columns. So matrix A has how many rows? If I look from left to right, I have one row here, one row here. There are two rows. How many columns does it have? Top to bottom. I have one top to bottom, one top to bottom, and one top to bottom. That gives me 3 rows. So my dimensions for my matrix is my rows by my columns. So I have a 2 by 3 matrix. So it's called a 2 by 3 matrix. That leads me to believe there's 2 rows and 3 columns. So that is how I identify my matrix by its dimensions. The dimensions of a matrix give us its size. The numbers of rows is always given first, and the number of columns is given second. So let's look at matrix B that I have here. Rows by columns, that's the dimensions. Now rows left to right, so I have 1, 2, 3. Columns top to bottom, I have 1, 2. So this matrix is a 3 by 2 matrix. 3 rows, 2 columns. The elements of the matrix are the individual values that are entered into your matrix. The number of elements or entries is the product of the number of rows and columns that you will see. So for example 3, if we go ahead and back and look at matrix A, it is a 2 by 3 matrix. How many elements does it have? If I multiply 2 times 3, I get 6 elements, 6 values inside that matrix. Matrix M, which is below this, is a 4 by 3. How many dimensions does that have? Multiply those two together. It has 12 elements, 12 values inside of that matrix. A matrix element or entry can be identified by its position in the matrix. In general, the notation A, I, comma, J refers to the element located in matrix A, row I, and column J. So let's look at it with actual numbers. So we want to look at this matrix and answer A, B, and C. So identify M2, comma 3. Well, what does that mean? Row 2, column 3. So go to row 2. Here is row 2. Go to column 3. Here is column 3. The number is 0. The next one is M1, comma 2. Row 1, column 2. So go to row 1, go to the second column. The number there is, or the value there is 2. Go ahead and see if you can find the last one. M4, comma What row, what column? Ask yourself that first. Very good. It's row 4, column 3, so the value is -3. Let's go ahead and get into matrix addition, subtraction, and multiplication. Those are the only mathematical operations that we need to understand when dealing with matrices. We can add and subtract two matrices if the dimensions are the same. The dimensions must be the same, meaning they must have the same row by column dimension in order to add or subtract them. To find the sum or difference between two matrices, we add or subtract corresponding entries. So if we look at matrix A and matrix B, let's figure out first what are the dimensions to see if I can even go ahead and add or subtract these. So, what are the dimensions of matrix A? How many rows, how many columns? Remember, it's rows by columns. I have 1, 2 rows, and 1, 2, 3 columns. Hopefully, matrix B will be the same exact row by column dimension. I have 1, 2 rows by 1, 2, 3 columns. So if the dimensions are exactly the same, I can go ahead and add or subtract them depending on what they're asking. So in this first example, they're asking me to add A plus B. I know the dimensions are the same, so I can go ahead and add them. I need to add corresponding entries. So if I pick up matrix A, put it on top of matrix B, what numbers would match up? Those are the numbers that I add together. 3 would match up with 0. So in this one, I'm adding 3 plus 0 is 3, and I put it in the same spot, the top left. 0 matches up with 2. 0 plus 2 is 2, and I put it in the same spot, the top middle. Next, I have 4. 4 matches up with -5. What is 4 plus -5? Very good, that's -1, and I put it in the top right corner. Now let's go match up the next test. -1, what does it match up with in matrix B? It matches up with 9. So -1 plus 9 is 8, and I put it in the bottom left. 7 matches up with -1. 7 plus -1 is -6, and it goes in the bottom middle. Very last one, 2 plus 3. 2 plus 3 is 5. So I matched up everything that goes together. And here is the answer when I added matrix A plus matrix B. Now let's go ahead and look at subtraction. When we look at a subtraction one, I'm doing the same exact thing. I am matching up the corresponding parts in matrix A with the corresponding parts in matrix B. But be really careful because you are subtracting here. So we want to make sure that we think about what we're subtracting and what it's going to look like. So 3 matches up with 0. 3 minus 0. I'm going to show you on the side here just so we don't make any silly mistakes. 3 minus 0 is 3. Next one, 0 minus 2. 0 minus 2 is -2. And the last one, 4 minus -5. 4 minus -5. Be careful there. What's 4 minus -5? Very good. The double negative becomes a positive, and that gives me 9. You see why I'm writing it on the side? Because with these subtraction and these negatives, we can easily make silly mistakes, and we don't want that to occur. Let's go to the next row. -1 minus 9. -1 minus 9. Well, if I'm subtracting with a negative, I keep change, change. Negative 1 plus negative 9 is negative 10. 7 minus 1. Ooh, be careful. I just made a mistake there. 7 minus negative 1. 7 minus negative 1. What's going to happen there? A double negative becomes a positive. So 7 plus 1 is 8. Next one. 2 minus 3. 2 minus 3. I'm subtracting a smaller minus a larger. So keep, change, change. 2 plus negative 3 gives me negative 1. And I have successfully completed my matrice. This matrice right here is the subtraction of A minus B. The next operation that we need to learn is multiplying matrices. It is called scalar matrix multiplication, and that refers to finding the product of a real number and a matrix. In scalar multiplication, multiply each entry in the matrix by the scalar or the real number. So if we look at our first example, it is asking me to find 4A. That means 4 times A. And it's wanting me to use matrix A from up above. So I went ahead and wrote it here so we had it, so we didn't have to keep going to look up above. So 4 times A. We are multiplying every single entry inside your matrix by the number 4. So if I look at the first entry, 4, I'm not going to have enough room here to write that actual step, but 4 times 3 is 12. 4 times 0 is 0. 4 times 4 is 16. I've completed that top row. 4 times negative 1 is negative 4. 4 times 7 is 28. And the last one, 4 times 2 is 8. So I have successfully multiplied that real number by the matrix. And here is my answer. Notice, matrix A was a 2-row by a 3-column. So it is a 2 by 3. My answer should give me the same thing. And I have 2 rows and 3 columns here. So I've successfully completed it. Let's go ahead and see if we can multiply negative 1 times the matrix B. I went ahead and put it here for us so we didn't have to go look up above. So you are multiplying everything in matrix B by negative 1, every entry. So 0 times negative 1 is 0. 2 times negative 1 is negative 2. And negative 1 times negative 5 gives me positive 5. A negative times a negative is a positive. Negative 1 times 9 is negative 9. Negative 1 times negative 1. A negative times a negative is a positive. And last but not least, negative 1 times 3, which gives me negative 3. I have successfully gone ahead and multiplied that real number, negative 1, by matrix B to get this matrix as my answer. Last question before we start some practice. Think about this. Consider a third matrix, matrix C. And the dimensions for matrix C are given right here. Can you find the sum of matrix A and matrix C? Sum means to add. Go ahead and think about this. What do I need to remember when I'm adding or subtracting matrices? What has to be the same? And I'm sure you're probably thinking, my dimensions have to be the same. Very good. You have to have the same dimensions. So let's go ahead and see. What's the dimensions of matrix A? Matrix A is the one we did above. And remember, we said it was a 2-row by a 3-column. look at matrix C. How many rows are in matrix C? I see 1, 2, 3. By how many columns? I see 1, 2. So matrix A is a 2 by 3, and matrix C is a 3 by 2. Are these dimensions the exact same? No, they are not the same. So can you add them? No. You cannot find the sum because the dimensions in matrix A and C are not the same. You can go ahead and look on Google Classroom for what you need to do now.